Hello everyone, today we're going to be talking about stoichiometry. The two key concepts that I'm going to be talking about in this subject is the mole map and balancing chemical equations, also known as BCE. The mole map has three things that you're really going to need to know. That is mass, which is how heavy something is, moles, which is units used to count particles in a bulk, and particles, which are just ions, atoms, and molecules. And first, we're just going to talk about um, how to convert from mass to moles, moles to particles, and just talk about how to convert them in general. First, let's just talk about from mass to moles. So to convert from mass to moles and moles to mass, you need to know the molar mass, which is basically just how much a substance weighs per mole. And you can find this by on the periodic table when you look under the element symbol. As you can see here, we have hydrogen. Under it, it will mention uh, some number, some mass, and in this case, it will be 1.01. In some cases, it will be 1.008. It's sometimes different. Each element can sometimes be different on different periodic tables. And to get from mass to moles, you need to divide the molar mass. To get from moles to mass, you need to multiply the molar mass. Now we're going to talk about particles. And for particles, the number that you need to use is Avogadro's number. Why it's important is for every 6.02 times 10 to the power of 23 particles, it equals to 1 mole. And basically, to get from moles to particles, you need to multiply or just Avogadro's number. And to get from particles to moles, you need to divide Avogadro's number. Basically, moles is the bridge of mass and particles. So basically, what I'm trying to say here is, if you want to get to mass to particles, you need to divide molar mass and then multiply Avogadro's number. And if you want to get the particles to mass, you want to divide Avogadro's number and multiply molar mass. So here's just a quick example of one of the questions that I did. Here is, we converted 26 grams of oxygen to moles. So here, the first step we do is we write down what we have. So the mass of oxygen as provided in the question was 26 grams. And if you were to look on the periodic table under the element symbol, like mentioned before, it would say that oxygen has a molar mass of 16 grams per mole. And here's the equation to find moles. It's N equals M over MM, also known as moles equals mass over molar mass. We plug in our numbers and this would give us our answer, 1.625 moles. And if here's just another example, just do the opposite of it. So to convert from moles to convert from moles to mass, so basically same thing as before, write down the information you're given, get your molar mass from the periodic table, and the equation for moles to mass would be mass equals moles multiplied by molar mass. And from there, again, you plug in your numbers and you get your answer. Here is an example of converting particles to moles. So here we just same thing, stating your stating the information that you have. So nitrogen ions equals 1.28 times 10 to the power of 24 particles. or ions, sorry. And we are going to have to use Avogadro's number, which is provided right here. And the equation for finding moles of particles is N equals nitrogen ions or whatever particle you're using divided by Avogadro's number. We plug in our numbers and our answer would be 2.13 moles. And here's an example of the opposite, so using moles to find particles. So we state the moles and that we're going to use Avogadro's number. And over here, sorry, it's a bit messy. To get the, sorry, I accidentally wrote an N there. That's supposed to be an O representing oxygen ions. And over here, what the equation would be is moles multiplied by Avogadro's number, which equals to 1.035 times 10 to the power of 24 ions. Alright, so next we're going to be talking about balancing chemical equations. So here's an example of a before balancing and an after balancing. And why balancing is good is because you can use it for finding ratios. So over here we can see that this hydrogen now requires two moles, two hydrogen atoms. Well, this one only requires one, so it stays the same, and over here it requires two. And why we do this is because of the law of convection right here, stated right here. And what it is mass doesn't disappear. So you can't just have hydrogen plus water and then all of a sudden one of the oxygen ions just disappear. That can't happen. It has to go somewhere. So that's why we always make sure that the same, whatever, if there's 3 hydrogens and 4 oxygens, and there has to be 3 hydrogens and 4 oxygens somewhere on this side. So how to balance. So over here is just a kind of a demonstration. I did my best to show how. So this is how you balance. You go look at the first element. So you see that you have 1 magnesium here. You go look the other side that has 1 magnesium. So they both have 1 magnesium. Oxygen, you go check that. On the left side has 1. On the right side has 1. Over here for sodium, it mentions that it says that it has 1 on one side and 2 on the other, meaning both sides need to have 2 sodiums. So we listed that down right here. And over here, chlorine, if you look on the other side, it has 2 chlorines, meaning that both sides also need 2. So putting that information together, seeing how there's 1 of each, 1 of sodium and 1 chloride here, and they both of those elements need 2, you put a 2 in front of here. That way each one gets a mole. Here is a better explanation or a better example. So here we have aluminum plus hydrochloric acid plus aluminum plus hydrochloric acid, and it makes aluminum chloride and hydrogen. So here's just an example. Aluminum has 1 on this side and 1 on this side, so nothing changes. If you go look at the hydrogen has 1 here but 2 over here. So we bring another 2 and put it right in front of this element. Then as you can see here, that also affects the chlorine, and that chlorine will then have 2 here and 3 there. And usually when this happens, you want to try and balance it so that way both sides will have the same. So what you want to do is you want to put a 2 here, and then whatever number this equals out to, you add that number here. So that would be 6 in this case. So 2 times 3 would be 6. So that's why you'd put a 6 there. And then from there, what you do is that 6 also affects the hydrogen. So, which 6 divided by 2, you just put a 3 right here. And since there's a 2 here for the aluminum, that would also mean that you'd have to put a 2 in front of the aluminum right here. And that's it. That's all I want to explain. Thank you for listening, and I hope you have a wonderful day.